Alright, in the last video we got this thing to like a basic working state, and it's pretty stable now. It's gonna work anytime you turn it on, until it doesn't, of course. But it still has some issues. First of all, I took all the RAM from my Robotron, or a lot of RAM from my Robotron, and stuck it into Stargate. I'm gonna put that back into Robotron because I got some parts. I got some monitor cap kit, power supply cap kit. I'm gonna replace all that shit. Got some RAM. I got 6502s. This is for the monitor too. Connectors for the power supply because those will get nasty. And I have the power supply rebuild kit. I'm probably not going to replace all the bridge rectifiers, just the big 5-volt one that sucks up all the amperage. And I got a heatsink for it because they get real hot. And then the big series pass transistors, we'll need to replace those because they get tired. And they can possibly short out and give your board like 9 volts, and that's not a good thing. Here are the regulator ICs. I might replace those. I'm probably not going to use the sockets because since the regulator ICs sense voltage, you want the connection to be as clean as possible, and there's nothing really cleaner than just directly soldering it to the board, as they already are on the power supply. And headers for the connectors and pins. So I opened up the good old memory gachapons, and we got all these labeled T-RAMs. I don't know what that is, but there's a couple Texas Instruments. At least I think. So I'll put these in. You've already seen me put memory in this thing last video, so I'm not going to bore you with that. Alright, so given this game's history with the backwards chips, I did double check to make sure I put them in the correct way. We should see a 0. It would have a memory error by now if it didn't. There we go. That's good. So that's with the new memory. And so this is our next issue. This shit. This is all stored in the CMOS RAM. And yeah, that too. This is also part of the same issue. It's trying to read from the CMOS RAM, and what that does is it stores the game's settings and high scores with battery-powered backup, battery-powered SRAM, so, you know, it holds its contents without having to be refreshed, just like the DRAM that we replaced just now. So, right now, it is unable to read from it, and it gets very angry. So, let me get my scope out. I already narrowed it down to what it probably is, but I'll show you my process real quick. You know, all I gotta say about that is get the fuck off my lawn. So we're gonna start tracing this. First, we're gonna start with the memory protect plug on the board right here. Don't mind this yet. So how this works is that we got a pull-up resistor to pull this line to 5 volts. And what that does is it goes over to here, one of the pins on 6E. And that's an, I think that's an OR gate. Let me double check. Yeah, it's an OR gate. So if either of those are high, then it's going to output out of 6E. And that goes into a NAND gate, I think that is. And then that goes all over to the right enable pin on this IC right here, which is the CMOS RAM, SRAM. So we're going to make sure that 6E and IC1 are switching as they should. Although I'm not able to really do IC1 here by double checking its logic because I only got 2 probes on my scope. So I'm going to assume that works if it's going to be switching on the output. That's probably a bad idea, but I don't think those usually go very bad. So we're going to start with the plug here. I already double checked the switch and made sure there was continuity through it. And so I'm using this as a switch replacement, so I'll have to reach in there. And we're going to go find 6E and whatever pin that is. So an issue I have with finding pin 6 on 6E is that it's underneath there. So we're going to find where it goes, and that would be pin 9 of IC1, which is on this little daughter board here. I'm not entirely sure why they did that. Maybe it was to adapt to a different IC, because the original one they had in mind didn't have the stock for it or something like that. That's kind of weird because that board is included on this schematic. I guess there's a transistor on there too, right there. I'm not sure what that does. Alright, so let's turn the game power on. We're going to probe pin 8 of that IC, so it'd be right here. Is that it? That doesn't seem right. I don't remember doing that. Yeah. I'm being silly. That is ground. When that is grounded, then it's acting like the door is open, so it should give access to reading and writing. So pin 8 at this point should be doing something. If we close the coin door, oh, got a good connection there. If I close the coin door, it doesn't stop, huh? What's going on here? Alright, no. I am being dumb. It's pin 9, that's the output of that AND gate. So, right now the coin door is closed. Now the coin door is open. Coin door closed, so it can access it. Or, open, closed, open. Alright, so that chip 6E is working. And then pin 8, the one I was probing before, is the actual read-write output to the chip. And so if I reset the game to where it wants to read and write to the CMOS, you can see it tries to do a lot more reading and writing right there, where it shows the error screen with the sound. So let's check the read write or write enable pin on the actual RAM chip itself. So this guy right here. This should be the same signal as we were just seeing. Uh-oh. So yeah, that's trying to read to it and write to it and all good stuff. So it's getting that signal, which is good. Address bus is 1 through 6. That's address bus 2, 3, 4, 5. Oh, I made it mad. Oh, I made it mad again. Fuck. Let's reset this. I'm jumping address bus pins and I'm making it mad. The 0 went away. It crashed. There we go. Let's bring this thing back. Stop getting mad from me being dumb. So, all the connections are connectified. So unless this IC on here is bad, and I can't tell because I can't actually look at its logic, that means that the CMOS RAM is probably bad. And that's not an uncommon failure for these things, so let's see if I can crash it again. Fuck you. Let's see how mad it is. Did the watchdog fire? You bet it did. So I already ordered some replacement parts for that, and here's that. That's the SRAM, or compatible SRAM, and a socket for it. So that means we're going to have to pull out, well, what they call the MPU board, but it's the CPU board, the CPU MPU board, and do some soldering. I gotta clean that shit up. I mean, surely at this point, if you're watching this video, you've seen somebody solder it before, but you gotta love it when you buy a big pack of headlights like this, and then the only one you can find is the one that's broken. These little tabs are flimsy and they break off and then whatever. And you cut the legs of the chips off real short, so it's kind of hard to grab onto them with this thing. Now listen here, plugger. Come on. We'll just empty this all over the floor and make a huge mess because, whoops, whatever. You gotta vacuum this room anyway. I know that since I made an assumption that the other IC was working in my troubleshooting, it's not going to be this way. But I like finding out the hard way, apparently. And it's kind of surprising how little there is no battery acid damage from these batteries here, except for slight leakage on the holders themselves. That's pretty rare for these things. Of course, you got, 2 sets of the tools you don't need. I'll have to go walk across the room to find one of my 2 pairs of these here. That's nice. Remember, organize your shit. I think it's ready to come right out. Very nice. I think I saved most of the pads. I'm not seeing any damaged pads. That's good. I like not breaking things. It takes a little bit of time though. I'm going to bend 2 pins down so that it kind of holds itself into place. Then what I like to do with these sockets is to solder down 2 of the corners. I'm going to stick my finger underneath there and push up on it, and then remelt that solder to make sure this thing's seated up against the board firmly. Remember not to touch the pin that you're heating up because that does get hot. There's a reason this metal is used for conductors in your circuit board, because it conducts things, and that includes heat. No, I don't like that very much. Okay. I was about to say the word new chip, but I see solder on this chip, so it's not so new. I see your trick. You've been pulled from a different board. As long as you work, though, that's all that matters. So now with the new CMOS RAM installed, I'm expecting it to come up with the error the first time, and then when we clear it out, it should reset the scores back to 0. Still got a 0 on the ROM board, that means it's happy. Adjustment failure, hit the button. And it actually brought up the defaults. So now if we go through the settings menu, all ROM's okay. No RAM errors detected. It's not going to take forever to check the CMOS. Or maybe it does, I don't know. I guess that's normal. Normal for it to take 5 hours to do that. No CMOS RAM error. Let's see here. CMOS RAM error or write protect failure. Huh. It still comes up with an error, huh? Let's see what this has to say. Maybe it's because these aren't set. Every 10,000 recommended. 3 ships for 1 credit game. I guess you could put 2 credits in and get more lives. I guess this is like Wizard of War or something like that. They're taking some inspiration. Pricing, free play. Well, more adjustments. Wow. Master difficulty control. There's a lot of stuff that you can do. Maximum difficulty. Recommended. Inviso time. Men needed to warp. Man, there's a lot of adjustments in this game. Letters for high score. What the hell? That's kind of funny. It's not 100%, I don't think. Well, we're closer than we were before. Factory settings restored. Alright, that's good. That's not good. So now we're going to run into weird issues because we're running with the switching power supply without a giant capacitor on the 5-volt line. I'm pretty sure this thing has a circuit on it that detects the power shutting off, and what it does is it holds the write protect high on the CMOS RAM as it's powering down. That way, no wait, I'm getting this wrong. I think you want your 12 volt and negative 5 to go off first, because then it will prevent it from writing to this. And then you don't want the CPU to shut off first, because if the CPU shuts off first, while it's powering down, it will hose the bus with garbage as it malfunctions due to low voltage. And then it can have a chance of erasing your high scores and stuff. So since we're not dealing with the original power supply that has a bunch of capacitance on the 5-volt line, we're going to get all sorts of weird, wonky errors, I do believe. Also, I'm pretty sure that the ground on the power supply is still the same as here, so this front switch should be functioning. But now I got batteries in there. It'll probably tell me that the either it's an error or the high scores have been reset, or factory defaults. Bookkeeping totals, adjustment failure. So now it reset the high scores because it got smoked. Let's change this. It did not save that. So it can't write to the settings portion, it doesn't seem. Let's try, maybe this switch is not referenced to the ground on the game board. Let's try this instead. Snap, crackle, pop. Resets. Maybe it is that IC on that board, I don't know. I don't think I have any NAND gate shit on me. So we're obviously not completely out of the woods yet. So I was looking at the chip that came out of it. This is a 5514, and I pulled up the data sheet and I compared it to the new chip, which is said to be compatible to 6114, and everything looks alright, and it should be working fine. but I'm not entirely sure what's going on here. So I also pulled up the datasheet, for the 5514 that came out of it originally, and it said that it's a fully CMOS version of 2114 RAM, which is the same SRAM that's used in Centipede. Do I have that? I got it here somewhere. Oh, there we go. So the reason why the 5514 was used instead of 2114 is that it's fully CMOS and uses a lot less power, and it's good for battery backup. But for stupid checking, let me throw this in here and see if it gives any other results. Maybe we just have an incompatibility with that specific chip or something. So obviously that's not going to be very good if I were to put batteries in there and expect it to hold my data. But it should run as is. What are you doing? What's arcing? Fuck you. Man, these things are such a pain in the ass. Something's arcing in there, and I don't like it. Yeah. What the fuck is that? Is it the power? Is it the power board? Alright. So I got that to go work. We're working now. This fucking monitor. Well, it's still not resetting the high scores properly. Come on. That's weird. That's weird. This is weird. Hook new hook. Alright. You know what, for shits and giggles, let's throw some double A's in there and see if it will prevent complaints. That's the fucking power supply doing that. That's definitely the power supply doing that. I'm surprised it hasn't wiped the fucking CMOS or the SRAM settings because my coin door was open. If it's shut, that means it shouldn't be able to write to the bookkeeping, and well, it'll write to the bookkeeping, but not the settings. Alright, so that's some weird results. I'll have to look into that a little bit more. I have to pull that fucking monitor out again and pull out that stupid power regulator board. No, I didn't see any visible arcing near the anode or the flyback, so I think that's still good, which is a good sign, because if that was arcing, that's not a good sign. They don't make reproduction flybacks for this one. But if this thing did go out, I could always order myself a G07 chassis, because I think this tube is compatible with G07s, as long as I get the yoke along with it. But first thing I'm going to do is wipe its hole. Come on, get out of there. Don't forget to wipe. I'm gonna shit, and I'm not gonna wipe. Get this dirt away from the stuff. That's like 23 kilovolts, so a little bit of dirt might cause some current flow, which we do not want. But yeah, it's always the tube that holds the charge, not the flyback, so don't be afraid of the flyback if the power's off and if the capacitors in the chassis aren't, charged. It's only causing vertical rolling every once in a while, so I think there's a loss in power. So I'm guessing what a real issue is the female side of this connector on that board right there. Now, I hate plastic clips as much as the next guy, but you know what? I gotta take back a little bit what I said about this thing. This whole thing just pops right off. You pull the two tabs out these plastic thingamabobbers, and this whole regulator comes out, PCB and all. So I guess the power does go straight through there. So I'll have to reflow those. It's probably not horrible, but we have the B plus pot that's been glued, so that does not move. You don't want to move that. But yeah, that's impressive. Look at that. Like, even if you take these two screws off right to the left and right of that transistor, this whole plate comes off, and this is a socket right here. Maybe those are bad. Maybe I should throw a bead of solder on that. Yeah, that's wild. Is that really the only rectifier diode on this thing? No wonder they needed such a huge capacitor to smooth out the voltage if you're only running one diode. That's crazy. No, actually, it's more likely that I'm just being a dumbass, because right here are the 4 rectifiers. At least that's what it looks like. Let me just stick my head in there with that fucking spider thing. Ew. Alright. So hopefully this thing is done playing around, because I'm not really in the mood to find the arcing bullshit. Okay. I'm not hearing it anymore. That's a pinball machine. Okay. Now what? You got something else going on here. What is arcing in here? So I figured if that 6114 RAM is compatible with 2114, Centipede and Millipede run 2114 RAM as their main system RAM. So I took 2 of those 3 chips that I bought, shoved them into here, right, these 2 right here. If I turn this on, we're gonna see if it runs, if that RAM is good, which it is, obviously. It is compatible with 2114, so this is working just fine. So this RAM is good. So why is it that I'm getting different results with 2114 and 6114 on the same board? So for now, I've decided I'm just going to leave the 2114 in there because it's working properly. However, every time I turn the power off, the high scores get nuked because the power supply is a switcher, and it doesn't have enough capacitance on the 5-volt line to hold the CPU powered up until the RAM becomes inaccessible from the... No, wait a minute. So how that works is that there's the power on reset, and that's powered by the 12-volt unregulated. So there should be an unregulated 12 volts along with the regulated 12 volts. And when the unregulated 12 volts that shouldn't have a capacitor or very little capacitance on it goes out due to the power shutting down, this will hold the reset line of the CPU low, or I think it's low, but it will basically hold the CPU in reset as the CPU powers down, so it won't do anything. At least I think that's how that works. So what we need to do is get the power supply working. However, there are some things I have questions about. First of all, this is the here we have the linear power supply. This is the connector we're talking about. The very first pin right here has that thing taped onto it. Also, on the power supply, all the fuses are good except for fuse 5. Keep that in mind, because if we scroll down here and look at it, fuse 5 goes from right here. This is the 6.3 or 11.5 volts AC. 11.5 volts AC. All right, 11.5 volts AC power coming into here for the -5 volts regulated, and also the coin door lights. However, on the coin door, we have R15, which is a resistor in line with the we have this resistor in line with the lights, so that will drop the voltage to the correct voltage for your coin door lights. And so that's just for the lights. Fuse 5 is blown. Fuse 4 is good. Why the hell is it that if fuse 4 is good, the lights are coming on, and this resistor is not getting heated? So they have something jacked up in here, because if I turn the power on, the power, we have 3 lights. We have the -5 volt light down at the bottom, because that fuse is there. Our lights are on. And so, let's see here. Shush. For some reason, let's go ahead and just shove this in here. That might do good. We have, whoa, let's not do that. That's not good. So this wire that they have hooked up to ground right here is the return line for the 6.3 for the coin door. And so right here, we should, if we poke this, so they have that reference to ground for some reason. If we poke this, this should be 0 or something. Why is it like -0.3? Is it getting pulled down that low? Is my transformer bad? That should be like fucking 10, 11 volts. Oh, I have it on DC. Excuse me. 5.4. I mean, it's probably still enough to get our -5 volts, but that's something strange going on here. Also, this fuse holder is very bad. We're not having any current going through there. So why is that winding not right? So we're supposed to be getting 6.3 at the light bulbs. We're not getting that high. That's tied to earth ground for some reason. Why? And the light bulbs are on when the fuse for the light bulbs is blown. So how is it getting current? I'm going to pull that wire out. In fact, fuck that wire. That's ground. It should not be referencing that to the ground. Fuck you. What is the point? Yeah, I don't know. So, I got some figuring to do here. Well, there is one nice thing that the owner who installed the switching power supply did, and that is for the coin door. So this coin door interlock switch here that locks up the CMOS goes through the coin door switch and grounds out the power supply. This returns to the power supply. So if this is not hooked up right here, it's not, the ground isn't the same. So what they did here is they ran this wire right here to the common, not even common, just straight ground. I guess the common and ground on that are tied together. So that's tied together. That way our coin interlock still works, but it still doesn't really explain why my light bulbs are lighting when they really shouldn't be. Also, let me pull this power supply out. And so another oddity, as you'll see right here, by this resistor for dropping the voltage from what's supposed to be 9.1 volts AC, which we were getting like 5. So that's supposed to drop the voltage down to a reasonable level for 6.3 volts for the light bulbs, because the light bulbs are rated for that. And you'll see that there's a little jumper that goes around it. Wire 1, note. Wire 1 connected only for cocktail applications, because the cocktail machine has a lot more lights, so you can deal with more voltage drop. Or it'll have more drop on the transformer, I guess. Either that, some of them are wired in series with each other to drop it. But so this power supply is not original to this machine. It has a different serial number. And guess what's there? That's wire 1. That's the jumper right there. So that might be the reason why this popped at some point. But I'm still not sure why putting this in would cause the light bulbs to light, because that's for this right here. It powers this bridge rectifier, and so the only thing that does, well, is really nothing. This shouldn't be connected to the light bulbs at all. All this right here is a little power supply for the negative 5 volts going to this little regulator, and so this is completely separated. So why is it that when you put this fuse in, that these lights come on? So I'm wondering if there's something wrong with the harness. So I traced it back to the coin door, and the only weird thing that I saw was that this right here, which is the return side for that 6.3 volts, was attached to this, which is the return, or the also just ground. This is like the return for the 30 volts coil voltage for the lockout coils, so that was tied together. So that's kind of funny, but it just went to ground. So I got it separated from ground now, I think. But I put the fuse back in for the lights, and it's doing good. These are like at 8 volts now, which is still overvolting for the little 6.3 volt bulbs that it calls for. So I don't know. I guess that's just how it's gonna be. I don't know. I think and I don't. I don't think. What do I got? Oh, these things have LEDs. This thing got LED'd, so this doesn't have the original bulbs in it anyway. This one. Oh, okay, come on. I need something to hold that open. That is not tied to that shit, so I don't know. That had the old tape on it. That 40-year-old electric tape that I had to peel off to find that. So I don't know if that was just how that is from the factory or what. That one has a slightly different power supply. This one is a little bit better. This one has a crowbar circuit, so if the series pass transistors down there, if they crap the bed, it will short the line out to ground and blow a fuse, and it'll save your boards from total destruction. This one does not. While that might sound like a bad thing, as long as you replace the series pass transistor and the regulators, I think it'll be fine. Because every other Atari game like this, these three right here, are all the same way. If the series pass transistor dies in a short circuit way, it will kill the game board. Not very safe, but that's just how it is. So let me pull this out. So at this point, I'm about halfway through the power supply stuff. I'm just going to go through most of all the rebuild stuff. I'm going to replace the regulator ICs, and I already placed the bridge rectifiers. I put the heatsink on the big one so it stays a little bit cooler, because those like to blow up. I got that chip pulled, so I just got to clean it up and solder a new one on there. Then I got to do that one. A couple diodes, capacitors, and the edge connectors, which are the biggest pain in the ass ever. Alright, so right now I got those chips installed. Now I'm going to be doing these connectors here. And I put a lot of cancer fluid on top of those so that it'll spread the heat nicely. It was a giant pain in the butt when I did it on my Robotron, but I have a little bit of a different strategy this time. So this time I'm grabbing this pin with my my flush cutters, put my fingers over here, just heating it up. Not even gonna suck with the solder sucker. I'm just gonna grab it down here and wiggle it around. When it starts getting loose, I'll just give it a yoink. Hopefully before the solder hardens up. Well, it'll make it easier to come out later at least. Maybe. This one's not even fucking... There's a pin, a key. Okay, ground plane. See, the problem with pulling these out is on the top side there are traces, and sometimes the solder will... all the traces up top will soak up all your heat, and it's just a pain in the butt. Like, these ground ones are going to be a nightmare. This is taking a lot of heat. Let's wiggle it around. That's getting hot on my finger there. Yeah, pull that sucker out. We'll see if I pulled up any traces. It'll be interesting to see, because this is not the usual way to do it. Here's a big old AC power pin with a fuse on it. I should pull those fuses out before I damage them from heat. Ugh. Don't touch the things you're soldering on. They get kind of warm. Because those are brand new fuses. I don't want those to die. Because then I'll have to wait for more to show up after I order them. Yeah, it's never a fun process, but at least I didn't lift any traces or tear any traces off or anything like that. I think from now on, I'll start from the middle and go outwards, so I don't have any middle pins sticking, and then I can wiggle it back and forth from the two outer ones instead from the middle ones like I was doing. So that was kind of a mistake, but that came out better than my Robotron ones did. Now I got it done, and this is why you double check. I've been working on this all day, so I'm getting kind of tired, so I'm like, So anyway, yeah, I set myself up the bomb. This one's backwards. Double check your work. If you don't, you'll be in pain. Well, at least this capacitor would be in pain. It'd blow up. I turned the power on, it would go bang. Alright, now that I double checked and even triple checked my shit, this should be ready to go. So, I'll put this in the cabinet and hook it up to the harness. I'll unplug every other board from power, and then I'll double check our voltages on this. Everything should be alright. Well, before I wire this up and check voltages and check functionality and all that good stuff, there are a couple things that need to be done. This connector needs to be replaced. This connector needs to be replaced, and this connector right here needs to be replaced. Those go bad. And the kit did come with the connectors for that, so I'm going to do that real quick. There is a mod you can do for this. I did it on my Robotron, but you know what? These things lasted for 40 years without them. And you probably don't need to do that. Especially considering this is going to be in my garage and only run a couple hours a week maybe. So, I mean, it's not really necessary. It just looks kind of good. I need to get the fuck away from that. Little heat sink on, or little heat pad on that regulator was touching the capacitor. You don't need to be cooking out no capacitors. I did put those in sockets. Kind of interesting to looking back on the old shit you did. Well, that's fine though. Yeah, that's Robot Ron. So I'm not going to do that mod on my Stargate because it's not necessary if we get new connectors. Man, you gotta wonder. Soundboard was working pretty good, but look at that.
It's all loose. Look at that space in there. How is that thing even working? I'm gonna pinch these in and it's gonna break. Watch this. Here we go. This is not the correct way to fix these. Oh shit. But it will get us by for now. We're gonna have some meltdowns here. These things are gonna get hot.
Alright, we've been at this for way too long today. How am I going to read those? So, I got the power disconnected from the MPU main board. Got the power disconnected from the ROM board. I need to get the caps for those. I got the power disconnected from the sound board. I have the output connected on the power supply. Coin door voltages hooked up. I think this just supplies coin door voltages for the lockout and the lights. That's it. This is from the transformer. Here we have coin door buttons, coin door or sound interconnect. So this is all safe from the power supply from now. This is video output. This is the coin door switcher dealy bopper. That only runs to the ground on here. And when the doors open, it's not connected in any way. So I got everything pretty much isolated from the power supply. I'm gonna plug this in. I'm gonna hope this shit just works because, well, regardless, I'm gonna be done for today. Okay, let's see if this thing blows up. Huh, 2 out of 3 lights. That's very cool. That's nice. Did I blow up any capacitors? Not yet, huh? Okie doke. Let's make sure there's no hot spots. And look at it go. Shocked by that one. Let's grab this. Let's see if that follows with what it's doing here. Come on, fade out. Well, that's my fault. Whoops. It's not going to play with this, huh? Is it just that light that's a bit funky? Oh. Come on, freak out at me. Shut down, let's go. So I don't feel safe plugging that into my board when it's doing that. I'm not entirely sure. And the voltage is good. Let's turn it off. Is there a test point? I mean, I guess I could have looked at it, obviously, but test point 1 right there is 5 volts. So I got a hold of that. We're gonna see if it blows up. Did I knock it into submission? Do I have a bad solder joint somewhere? I don't know if I trust that, because if you drop 5 volts, I'm pretty sure it starts killing RAM on these boards. 4116 RAM is not very forgiving if you don't have a power supply that's working properly. Test point 6 is ground. That's probably grabbed onto down here, isn't it? Yep, okay. Okay, let's check some other voltages. Here we got test point 4, which is 12 volts.
4 is probably like clear the fuck over here. No. 4 is on the other resistor.
This is 12. 12 looks good. That's good 12. So we have regulated 5, regulated 12. We're going to poke regulated -5 here at test point 5.
Which is over here somewhere, because that's our regulator. No, it comes right past here. Oh, a nicely designed board.
-5.1. That is good. And unregulated 12. There might be a test point for it. I'm pretty sure because it comes down through here. That's 27. Where is unregulated 12? It probably comes off the 5 volt area. Test point 3.
Is that the one in the back? That's 2. 3 is right next to the rectifier, because it would be. It's just coming straight off that thing.
Right into your face. -15. -15. -15? -15. Test point 2 is positive.
Let's try test point 2. Get out of there, come on. Try the short shit out. That'll be a fast track to having it not working. So that's unregulated 12 positive.
And that is used by the game board for reset circuit. And so it appears
all of our shit is correct.
I'm going to turn it off. I'm going to let it sit and cool and think about it for a bit.
And then I'm going to turn it back on after maybe 10 or 20 minutes. And then we'll
see what it thinks about the 5 volts then. We're going to see if it explodes. Keep an eye on the voltage for 5 volts since that was our iffy boy. I didn't see it because I didn't have it plugged in, but that did light up. Fuck. This is weird and wigging me out. The game booted. Alright, so it's running on its old power supply now. That's good. I'm not gonna fuck with that right now, so go fuck your shit. We have the 2114 in there with the double A's. I might do a test to see how long that's gonna last that way. Let's check our bookkeeping. Let's reset everything. Restore factory settings. Clear bookkeeping totals. Reset high score table. Bam. High score table reset. Factory settings restored. Hit the button. That's not restoring correctly. There's something wrong with that. Yeah, that light, that LED must be going out because I'm still at 5.07 volts on the power supply and that light is out. So that thing is a piece of shit. We're one step closer to working stuff. I can remove the switcher now. That makes me happy at least. There's one thing I did get done today. CMOS RAM was not one of them. Monitor working was not one of them. Not that I started out with that problem in the first place. So let's get this pile of crap out of here. But yeah, I got some monitor servicing that needs to be done.
So I'm going to have to pull that thing out anyway.
So since I'm having so much weird problems with the CMOS, I've been poking around signals in this area right around here. First, I use my scope to check this inverter that drives this NAND gate here, and that's doing its job. My scope doesn't have enough inputs to check what that NAND gate is doing, but I started poking around with the signals in specific, or all the signals. And so this one will flip on and off with this right here. I'm not sure, but that'll control that, and it only flips on and off when it wants to, you know, check the CMOS RAM. And that's hooked up to 2 of these pins, so this is actually kind of like a three pin deal going on here. And then this middle one comes from the CPU, which is Q. That's one of its clocks. I'm not sure if the clock comes from the CPU or not on this thing, or if E. I think Q might be like inverse clock, and E comes from the clock signal shit. So if Q is inverse clock, pin 5 should be cycling constantly. So let's see here. I was poking around with that. So if this is held high from not being accessed, and this is clocking, then the output of 6 should be going nuts. It should be almost like a clock. And that would, you know, control this whole deal here, I think. So, yeah, the chip select. So I poked pin 6 on that IC right there, and I'm getting that. And watch this, as I poke this little wire right here that's running from the board to the daughter board. So that's definitely a problem. So let's fix that. So I guess if that wire wasn't working properly, it would not have been protecting the CMOS RAM from certain reads and writes. Not properly. I don't know. Let's find out. If the monitor wants to behave today. We're all restored. Haha, gay. Everything looks normal. All right, let's cycle the power. Yeah, if that was the problem, I was really close. No. Actually, I'm dumb. Excuse me. I need batteries for this to work. It's always going to tell me that, but it's not giving me adjustment errors. Okay, batteries installed. We have default stuff. Turn the power off. And if the CMOS RAM was not going to work, it would have, you know, deleted all that shit immediately. So, time won't matter for power down. All systems go, and CMOS is working now. Very good. Okay, that makes me happy. And so it's been a couple days later. I put a couple scores on here. I'm number 2. Anyway, so I've been running it for a couple days just as is. The monitor seems to have chilled out. I'm not entirely sure why it was arcing that day, but I'm pretty sure it'll come back. So we'll have to do the usual monitor service since there's still some fold over at the top until it heats up. Let it run for a while and the fold over kind of goes away. So it's definitely got capacitor issues, which is a given for how old this thing is. But yeah, besides that, we got a little cosmetic work that I'll have to do. Otherwise, that's just the current state of the game now. The CMOS is working. The battery is holding the, causing the RAM to hold the data while the power is off, and things are generally looking pretty good.